Welding is the process that uses heat or pressure to join two materials together permanently. First, we'll see the wire and scratch brush. The wire brush we see here is a metallic wire brush used for removal of rust before welding and cleaning of the weld after welding. Scaling hammer. Here we see a scaling and chipping hammer. It is used to remove solid impurities like slag or scale after welding. DE spanner. DE spanner is used to open nuts and bolts in cylinders, etc. Tongs. Tongs are used for handling hot workpieces during and after welding. Typical uses are adjusting the workpiece during welding and dipping the product in coolant after welding. Hand gloves are worn by the welder. They are to protect any kind of injuries or burns to the welder. They are made of leather, asbestos, etc. They prevent sparks flying out of the arc welding to reach the welder. Welding goggles. Welding goggles are dark colored goggles worn by the welder during gas welding. These protect the welder's eye from heat, light and smoke during the welding process. These are essential to be worn during gas welding. The screen holder contains a protective screen and is to be put on the face of the welder as well as others standing nearby during welding. The welder should not see the arc directly because of the ultraviolet rays radiated during welding. Electrode holders. Electrode holders are used to hold the electrodes in arc welding process. They complete the electrical circuit for arc welding. Gas sparking lighters is used to light the gases at the tip of the gas torch during gas welding. Spindle key is used for opening and closing of valves of the gas cylinders. Pressure gauge is used for measuring the pressure of oxygen and acetylene gases being delivered. Oxyacetylene cutting torch is used for mixing the oxygen and acetylene gases in desirable volume and afterwards combustion of these gases at the tip. They consist of two ends, the tip and the entry valves. The entry valves are two entry valves for oxygen and acetylene. The tip is of highly conductive material, usually copper. The oxygen cylinder has a convex shaped base to improve strength. The outlet valve is located at the top of the oxygen cylinder and is provided with a key and pressure regulators. The oxygen cylinders are always painted black. They contain 6.25 meter cube of oxygen stored at a 130 to 140 atmospheric pressure. The ducts provide the oxygen to the welding cutting torch. The acetylene cylinders are made of high-speed steel. Here the base is convex in shape. This is a pressure gauge and this is a key. The color of this cylinder is maroon. These cylinders are filled with acetone which can absorb up to 25 times of acetylene and the acetylene is stored at 16 atmosphere. Rubber tubing is used to connect cylinders with the torch. The red colored tube supplies the acetylene while the green colored tube supplies the oxygen. The flame is set for carbonizing flame. That is, the acetylene quantity is kept higher. The flame is then produced using the lighter. Now, this is a carbonizing flame. Now, how to go about the workpiece? First, the workpiece is cleaned by the wire brush to remove any rust from the particles. Now this carbonizing flame we produced is adjusted to make it a neutral flame by increasing the quantity of oxygen. Now this is how a neutral flame look like. The electrode is dipped in flux and this electrode is bent at 90 degree. Now, this electrode is welded at the two corners of the workpiece. These are called tags. These are applied to hold the workpiece together. Now, gradually moving backwards, we can see that the welding is completed very slowly. The torch and the electrode are kept nearby and near the workpiece. We can see here that the electrode is bent at 90 degree. The scaling and chipping hammer are used to check for any defects in welding and removing the layer of slag and scale formed over the welding. Afterwards, this workpiece is dipped in water to cool it down and then scratched using a wire and scratch brush. Now we are going to show you the different types of flame. First, we'll show you an oxidizing flame. An oxidizing flame, this is an oxidizing flame produced by increasing the quantity of oxygen and reducing the quantity of acetylene. It is of short length and produces a lot of noise. Now, changing it to produce a carbonizing flame here, which is having a lot of acetylene. Now, this carbonizing flame is not so hot, it is longer in length. So, we'll show you the uses of oxidizing flame. Oxidizing flame has a very high temperature and is used to cut materials. As you can see here, it is very easily cutting a sheet of material right through. Now, a carbonizing flame shown here is a very long length flame, but it does not produce a very high temperature. So the normal welding process possible normally is not possible here. Here we have to go through a brazing process. The brazing process uses copper electrodes to braze the workpieces together. You can see that the flame is very scattered and it is not pointed, so it cannot melt the workpiece to form a proper weld. You can see here that a puddle of electrode will be formed which will spill all over the workpiece. As you can see, the brass electrode which we have used has spilled all over the workpiece and has formed a puddle. This weld formed is weaker than the normal welds. Now for some of the precautions that have to be used during gas welding. Firstly, the gas torch has to be always moved in a forward and backward direction and it should be kept down when not in use. It should never be moved laterally, it should never be moved up and down. Now, we can see that during welding, the electrode should be turned at 90 degree so that the hand of the welder is not exposed to the welding gas. Now, for closing the glass flame, first the acetylene supply is cut off and afterwards the oxygen supply is cut off. This is to ensure that no acetylene is left unburned. Thirdly, wearing of goggles is very important. As you can see here, the difference we have observed. Arc welding. Arc welding is done to join mild steel plates. Here the steel plates are 75 mm long, 25 mm wide and 6 mm thick. We'll try to make a T-joint as shown in the figure. First we'll mark the center of the workpiece. Now the center of the larger workpiece is being marked. Benchwise or fixture. The mild steel table is used to place the workpiece for welding and provide earth. This is the DC arc welding transformer. Power supply is required to fuse the metals for arc welding. So we use DC arc welding transformer. The DC generators supply the power for this DC arc welding. These motors use AC power, but IC engines can be used for portable powers. AC transformers are used for AC arc welding. They have the advantage of low cost and maintenance and are also free from sounds. The type of weld, depth of welding, etc. determine the current required. Arc welding must be done with proper protection. Wearing shoes is very important. Wearing apron and gloves is also required. All these kinds of protections protect the welder from getting any kind of sparks hitting him in his clothes or in his body. Secondly, protective screen is also required to protect from ultraviolet radiation. The electrode holder holds the electrode in the groove provided. The person must just fit them into it and fit them tightly. The earth is shown here, which completes the circuit. Now, after the bodies are fixed in the fixture, here we see our steel plates are fixed in the fixture. We'll try to weld the T-joint as shown in the figure. So, the first step is that after putting the electrode in the electrode holder, we have to check whether the electrical circuit is complete. Checking this is very easy. Just hit it against the table and see whether there is a spark produced. If yes, the circuit is complete. Now we'll use a protective screen and we'll try to generate. So here is the welding. The welding is done very easily. You'll have to just move Now we have seen here that a tag is generated which holds the workpiece together. Now this tag, now the complete welding is done just by hitting the workpiece and moving it slowly. Now, a scaling and chipping hammer is used to remove the extra scales and the slag formed. As you can see, the slag is dropping on the table. Now, the work of scaling hammer is done. We'll dip this workpiece in water to show that to cool down this workpiece. We take care to use only tongs to hold this workpiece. It is now cooled. Again, we'll use wire and scratch brush to remove some extra impurities present on the surface and to make the weld smooth. So the welding is now complete. Now here are some precautions. First of all, if the electrode gets stuck during arc welding somehow, to remove the electrode, we have to just move the electrode laterally and not vertically. Moving it laterally does the job. For chipping the workpiece, it's a simple rule. We have to chip the workpiece in a tilted position.